Hey guys, welcome. In this video, I'm gonna explain and demonstrate segment routing on demand Nexthop and SR PCE in Seamless MPLS Network. My name is Hinwato. I'm a Cisco Technical Solution Architect. This video is part of Cisco segment routing and Cisco NSO demonstration. In Seamless MPLS, we need to use the BGP Label Unicast protocol, which RFC 3107, and introduce more protocol layers in the transport technology. So, in this demonstration, segment routing will address the challenge and constraint of point 1 and 2 about the complexity in transport protocol layer, and also to address the limitation of RSVP point 4, 5, as well as we will introduce the latency awareness and capability in the segment routing network. Let's understand the topology. In the topology, we have two preferred topology, which is red link or red interface, which is a bandwidth preferred topology, while in the green link or interface, they are our latency preferred topology. Red link, we have higher bandwidth in the bundle Ethernet. In this topology, if we are gonna use Seamless MPLS with BGP label Unicast, we need to establish the ping dotted line, which is the BGP LU session from PE to the inline RR, and then inline RR to the RR, which is in this case is router 93, and then across to the inline R again, and then reach to the other PE. So there will be a necessary to create the BGP session on top of the existing LDP or RSVP, or in this case, SR level 2. While in this topology, we don't use this BGP label Unicast. We will introduce the SR PCE as the centralized point for PE to consult how to get the router PE on the other domain. This is the topology that we are gonna build. So as you can see, router 1, 2, 5, and 6 are part of the OSPF process ID 2, which is area 0. And then router 1, 2, 3, and 4 also within its one OSPF domain, OSPF process ID 1 at the same area 0. And then router 3, 4, 7, 8 within the OSPF process ID 3 with the same area 0. In this topology, router 1 and 2 has two multiple OSPF domain, as well as router 3 and 4. Router 1, 2, 3, and 4, they have the BGP link state session to the SR PCE in the blue dotted line, while router 5, 6, 7, and 8, they are PE, which has the PSEP session, the red dotted line to the SR PCE. Let's check on the router. I'm gonna show it first on the NSO configuration, and later we verify it on the router console. Here, this is the NSO web user interface. I'm gonna see on the transport service. Let's see on the router 5. On the router 5, which is the PE, we activate the segment routing here. And then the segment routing, we have activate the SR PCE client, which activate the PSEP session. And they are the interface within the OSPF. That's it. Let's see on the router 1. Move a bit here. On the router 1, This is the border in the Seamless MPLS multiple OSPF domain. So on the OSPF domain, we select multi here, and also we activate the BGP session here, which is we will select the BGP link state. BGP peer to the 93 and 94 with the BGP role, BGP link state, BGP LS. For the multi, we have two multi OSPF domain, which is OSPF process ID 1 and OSPF process ID 2 here. And here we define the interface that includes in the OSPF process ID 1. And we will do the same thing in the multi OSPF process ID 2. So router 2, 3, and 4 will be configured with the same way. So let's see on the router 93, which is the SR PCE. Okay, on the SR PCE, we activate the BGP link state here, BGP session, and we define who is the BGP link state client here, which is R1, 2, 3, and 4. Let's see on the router. Let's see on the router 5, which is the PE. As the benefit of the Seamless MPLS, we segmented the OSPF routing table so that router 5 is actually doesn't need to know about anything happen in the other OSPF domain, such as OSPF domain 1 and 3. So any instability or link failures in the OSPF 1 and OSPF 3 will not impact to the OSPF routers within the OSPF domain 2. So I'm in the router 5 here. Let's check the OSPF. So router 5 can only see and concern about the 1, 2, 5, and 6 here. So router 5 doesn't have anything beyond the OSPF domain. Okay, and then this is already segment routing level. Here, you see, that's it. It's very simple and concise on the routing table and also on the MPLS forwarding table. So let's see on the PSAP. So segment routing, traffic engineering, PCE, IPv4. Here we have the PSAP session to the SR PCE 93 and 94. So let's see on the router 1. Router 1 is the border router here. Let's see. Router 1 has two multi-OSPF processes ready. Run router OSPF. It has OSPF router process ID 1 with the interface selected here, and also activate the channel routing and MPLS forwarding. And also he has the router OSPF 2 with the same area annual configuration and the related OSPF interface. Also activate the seamless semi-routing MPLS here. And let's see on the BGP link state. So BGP link state, he has the BGP link state session to the SR PCE here. Let's see on the SR PCE 93. On the SR PCE, let's see on the BGP link state and sound. It has 4 BGP link state neighbor 1, 2, 3, and 4, and they are already advertised 83 prefix. So at this moment, BGP link state has the full visibility across the multiple OSPF domain. OSPF domain 1, OSPF domain 2, and OSPF domain 3. Those information are retrieved from router 1, 2, 3, and 4. They are the border router within the Seamless MPLS domain. Let's see on the PCE IPv4 here. And also SR PCE has the PCAP session to the S router, which are the PE router 5, 6, 7, and 8, and his redundant SR PCE here, router 94. Now, let's see on the VPN service that we have created within the Seamless MPLS using the Samaritan OnDemand Nexthop. I have configured the LTVPN service network slicing, network slice 5G, and then we have two services within the same VRF, only one VRF, which is 5G. The services are 5G control here and 5G user. We have planned to have it on the router PE 5, 6, 7, and 8. By using semi-routing on-demand Nexthop, we'll have the benefit that will simplify the automated traffic engineering setup and creation across all PE following the SLA requirement. In this case, the low latency service will follow to the low latency part, and while the high bandwidth service will follow the high bandwidth part, which is the blue line, and the green line is the low latency part. In this case, it will simplify the scenario such as how many PE policy required for 50 PE and 2 service if we configure it manually one by one every PE. So it will require around 2,400 plus PE policies. This will create more complexity and more operational concern, and most likely will introduce error too. So that's why Cisco innovates how to automate and fulfill the SLA requirement in the automated fashion. This is the Cisco semi-routing on-demand Nexthop will address this concern. Let's see on the NSO configuration and later on the Cisco router. Let me go from the NSO. It's on the VPN service here now. So let me go to the 5G. On the this is the 5G network slicing menu. We have defined it as the L3VPN with the ID 500. It will be used as the VRF ID. We have configured the SR on-demand activated. The node lists are the PE involved within this VRF 5G. So as we see here, we already configured on the PE 5, 6, and 8. Let's open one. On the VRF, on the router 5, we have configured two services here, which is the 5G control and the 5G user, which is later implemented in the sub-interface level. So on the 5G control, the low latency parameter is false. It means that it will follow the high bandwidth path. While the 5G user, the low latency part here, the low latency parameter is true. It will follow the low latency part, which is the green link. In this case, we have defined the 5G user will use the green link, which is the low latency part. Okay, let's see on the router here. I will access the router 5. So router 5, VRF 500 is the VRF ID of the 5G BGP. We have two destinations here, router 6 and router 8. So as you can see here, if we trace out to the VRF 500 towards the router 8, which is 8511, let's see. 8511 is 5G control and will follow the blue line path 5, 1, 3, and 8. 513 and 8. Let's trace on the 5G user port here, 8521. 5G user 8521. If we follow to the router 2, router 4, and router 8. 5, 2, 4, and 8, which is the green line path. All this path is actually has been assigned by the SR PCE semi-routing policy. Here we have defined, we have two on-demand policy. Policy number 1, which is dynamically will be assigned by the PSAP, is the color tan for the low latency path. While on the on-demand policy, the second on-demand policy, also consult and will be assigned by the dynamic PSAP, is for the high bandwidth path with the color 500. And all this automatically traffic engineering setup will be assigned for each PE destination. As you can see here, the segment traffic engineering policy tabular on router 5. At this moment, they have two neighbor PE, which is 6 and 8. Here you can see 6 and 8. 6 has two policy here, 500, which is the high bandwidth path, and 10, which is the low bandwidth path, for two different services. This also for the router PE8 as a destination. Let's do the on-demand scenario here. I'm gonna delete the router 6 PE here, and I will include the router 7 in the network slicing of 5G. So the traffic engineering policy to the router 6 will be deleted automatically, and the traffic engineering policy for the router 7, for the blue line and the green line will be created automatically too. Let's see. I'm gonna do it with the NSO. This is the on-demand scenario will take place. Let's see 5G. What I'm gonna do is I will remove the 5G6 here, delete, and I'm gonna add the 5G router 7, and I need to fill in all the parameter here. This is router 7, and the node slice here, which is a sub interface and services, 5G control, 5G user, and remember, what I'm doing here is the same VRF, only one VRF, which is VRF 5G. 5G control is not low latency, the interface here, and this is the barely requirement. And the VLAN ID, this is 7, 5.0, 1, 24, okay, connected. Let's fill it on the 5G user. Remember, 5G user is a low latency. I'm going to select 2. And this is 3. And next, VLAN ID 7520, 7521, 24, connected. And we review on the native config CLI. So it will do some changes on the router 5. On the router 6, it will no, because it will delete the services and VRF there. While on the 7, it will introduce and configure the new VRF there along the QoS. And then on the router 8, it will adjust some parameter. That's it. Let's see commit. What will happen here is router PE will be excluded and deleted from the network slicing 5G VPN. All the traffic engineering related to the router 6 will be deleted automatically too, while we introduce a new PE, which is router 7, to be part of the 5G VPN network slicing, and also it will create automatically the traffic engineering towards the router 7 and also from the router 7. Okay, let's see on the router now. I'm commenting on the configuration. Okay, router 6 is out of sync. Let me sync the router 6 first. Router 7 also out of sync, and router 8. Let me sync from these two routers. Okay, let me commit again. Cisco and NSO is configuring two routers at the same time. Okay, let's check on the router now, router 5. As you can see, now the router 6, the operating status is down, and we have a new policy with the endpoint router 7. Yeah, so it will take some time to delete the existing policy here. Let's see on the router 7. Yes, now he has to the router 8 and router 5. Let's see on the router 8 now. So, yes, it's also here. And then we see the operating status for the router 6 is also down now. As you can see, router 5, now he has the policy to the router 7. Let's show route VRF 500 and BGP. See that we only have 7 and 8 now, no more 6. Let me trace VRF 500 to 7511 from 5. 7511 is 5G control. Control will follow the blue line. I think it will go straight line. Yes, 1, 3, and 7. 1, 3, and 7. 5, 1, 3, and 7. Well, to go to the 5G user, which is the low latency service, we will follow the green line path. 247 here. 247. This we don't need to define manually hop by hop for service SLA here, because by requesting the path to the SR PCE hub within the Seamless MPLS network, the SR PCE assign the right path based on the SLA. So segment is let's see to the router 7. Let me find the router 7. Okay, here. This is 500, which is the high bandwidth path. Destination router 7. He is consult with the PCE here. This is enemy. The PCE assign the right path based on the SLA here. Let's see. This is the color pen. Color pen is the low latency service. Destination router 7. And also consult the based on the PCE analysis. This is the recommended path for the low latency service. As you can see, there is no more endpoint 6 here. So since router PE6 is already excluded, it's no more part of the L3 VPN 5G network slicing. So all traffic engineering to and from router 6 are also deleted and terminated. while the router 7 now is created automatically to and from router 7 based on the services, the high bandwidth services and the low latency services. This is the beauty of segment routing on demand Nexthop, and we also apply it in the Seamless MPLS. And in the Seamless MPLS, we don't use BGP label Unicast. This will be another advantage, another value that we simplify the network, that we don't use LDP, we don't use RSVP, we don't use BGP label Unicast. So we only use the new OSPF with the semi-routing and the features semi-routing on demand for the traffic engineering. And we use NSO, the Cisco Network Service Orchestrator, to do all the provision and configuration automation here, and SR PCE for the centralized path computation element. That's it, guys. I hope you can see all the beauty of SR PCE, semi-routing on demand, and Seamless MPLS network. Thank you. And this is for the further information. Please access semirouting.net tutorial, semi-routing traffic engineering, and there are great books about semi-routing part 1 and part 2, which you can also access it from the Amazon. Thank you very much.